and welcome to our next edition of the Ask Tom Office Hours about spatial technologies. We have a very fascinating topic today to talk about. We called it Spatial Gets Moving in Space and Time, and you will learn about how you can visualize and analyze streaming data with location information attached. We will also talk about how to determine patterns of proximity between moving objects. You will hear about what geofencing is, or how you can analyze spatial patterns over time. Since the topic is worth of talking hours about it, we have split it into two sessions. The one today and a second one tomorrow at the same time. Both sessions, my colleague David is going to present. Some other colleagues, of course, have joined the session as well. So there is plenty of gathered expertise to handle your questions during and at the end of the two sessions. So please use the Q&A area in Zoom for your questions or remarks. Okay, so David, let me hand over to you.
Yep, so thank you, Karen. I'm David Lapp. I'm a product manager on the spatial team along with Karen. And we're going to be talking today about Oracle Spatial in both the space and time context. And actually, the first thing I'm going to do, I think, is to probably turn off my video because I'm going to be showing you some things on a screen way over to my left, and don't want to be looking sideways at everyone. So thank you very much for joining. And the context today is all about both space and time. So I think most of you are probably generally familiar with Oracle Spatial and the fact that we manage location-based and geospatial information natively in the database. But the time dimension also allows us to do some really interesting things. And turns out that the spatial platform in the Oracle database just provides a lot of opportunity to exploit both the space and time dimensions. So just to level set for anyone that is coming in a little bit new in terms of what this whole Oracle Spatial thing is, we start at Oracle with Oracle Database with the premise that everything happens somewhere. So all the information that we manage in Oracle databases, our business systems, transactional systems, analytic data, data marts, everything that we're storing in some way relates generally to some sort of event, incident, activity, transaction, something that's happening somewhere. And that location and the relationships between those business entities, oftentimes location is the key factor that can relate and integrate and provide insight into them. So with Oracle, location, spatial information is just another data element in the Oracle database in general and the Oracle Autonomous Database in particular. So the Oracle database, Oracle Autonomous Database, again, in particular, is a converged database, manages all forms of sort of traditional relational data, but lots of other forms of data that all live together in this converged environment. Spatial is just one of them. And by doing so, we can take our traditional business data and leveraging that location dimension, we can start to ask all kinds of different sorts of questions about the way data relate to each other based on proximity and containment and just location relationships between things. Ultimately, do that all in the context of all in the business context at the end of the day to make better decisions, in part based on location. So that's sort of the premise behind spatial. And to get a little bit more specific about that, really what that means is that that information that relates to point locations like geocoded addresses, what we would call linear or line-based locations, which would be things like utility lines and road center lines, and regions or areas or polygons, things like postal code areas or counties or municipalities or sales territories, trade areas. All of those shapes, those geometries are stored natively in the database in a native type along with their business information and can be used to extend the reach of database queries into that location realm. So ask questions about our assets and how they relate to areas of risk or hazard. Ask questions again about proximity and all sorts of location relationships, and do that just in the traditional mainstream context of the Oracle database. And that's every Oracle database, every Oracle cloud database, autonomous, your own customer managed database on premises. And it's actually beyond just those simple points, lines, and polygons. I have a picture of some aerial imagery here, and that's another type of spatial data we manage. And there's quite a wide variety of others in addition to that. So to get even more sort of meat and potatoes with exactly what this means in a practical sense, and again, this is all just before we add the time dimension into the discussion. Spatial in Oracle database is just a native data type, and it lives alongside string data types and number data types and date data types, etc. So you can see on the left, I just have a table called parcels that has some sort of traditional columns that you'd expect and a geometry column. The column could be named anything. Here it's named geometry, but the important thing is that the data type is this native spatial data type called SDO geometry. And that's how you just add geometry into a table. And then on the right, we see an example of asking a question of that data, a spatial question. And in this case, I want to know which of our parcels are within a predicted flood area. And that question becomes just a typical SQL query. And in the where clause, you see this SDO inside, and that's one of this huge array of SQL operators and functions that allow you to ask all kinds of spatial questions. So managing spatial data in Oracle is really just an extension of the traditional sort of way that you manage and query data already, and just extend that to include these native spatial features. And I just mentioned points, lines, polygons, and the fact that there's actually a lot more than that we manage in terms of geospatial information and models and analytic capabilities. The point, line, polygon basics are really a large part of what everyone does in Oracle Spatial, but there's a lot of additional things as well. A couple of those, or a few of those, are the things that we're going to talk about in this spatiotemporal context. So there's things like managing spatial networks, connected networks, which allow you to not just manage location, but understand and analyze the way that you can traverse through a geographic network. And just as an aside, folks will generally hear and refer to and sort of know spatial as part of this spatial and graph family, or sort of a feature that's oftentimes referred to collectively, spatial and graph. And networks is sort of a key sort of cornerstone of where that common background emerged from, because networks are really just a geographic example of a graph where you have vertices and edges, and you traverse through them, and it just so happens to be geographic in nature. So just as an aside, there is an actual sort of technical underpinning behind where spatial and graph kind of emerged from together. But moving on from that, there are other features in the database, and we're going to talk about a couple of them: geofencing today, this duration of proximity tomorrow. So there's a broader array of things that you can do with spatial when you get past the essentials. I also want to call your attention to the fact that there is also an application, a tool called Oracle Spatial Studio, which is a tool to make it easy to use those spatial features of the database without having to do the SQL coding or the web coding when it comes to wanting to visualize and create interactive maps. Oracle Spatial Studio, while I'm not going to be presenting, we're not talking about features of Oracle Spatial Studio that are themselves spatiotemporal. Really, what Oracle Spatial Studio is going to do in this session and in general is it makes it really easy to take advantage of the spatiotemporal sorts of capabilities. And in fact, there are some aspects just in terms of visualizing things moving around in space and time that Oracle Spatial Studio does provides. I'm going to touch on that as well. So Oracle Spatial Studio is a really convenient way to work with all these spatial features. And again, as you'll see, it's also a way to both visualize things that are sort of animating and moving in space and time, but it's also a really nice way, and hopefully you'll agree with my saying that, it's a really nice way to be able to harness some of these back-end features like geofencing or what have you, and have a really easy way to be able to visualize and sort of capture what those features are doing in a really easy self-service way. And I should mention here, for anyone that doesn't know, Spatial Studio is one of the apps that you get along with Spatial, just as being a customer of Oracle Database. And it's a free application that you can deploy on your own server, or you can deploy to the Oracle Cloud from the Cloud Marketplace. And I'll be using it as sort of the vehicle to show some things today and tomorrow. So in general, sort of stepping back at all the different ways that people can take advantage of and sort of leverage Oracle Spatial, sort of break it into a few categories. On the top left, there are the sort of the coding, roll up your sleeves based approaches when you're just working with straight SQL, the native APIs, and there's, in addition to the SQL and PL SQL APIs, there's a native Java API, and then there's sort of dev tools and dev frameworks, Apex, Oracle REST Data Services, Python, and more, where if you can talk to the Oracle database, you can work with Spatial through those developer platforms. Both Apex, Apex, for example, has native built-in features to use Spatial. So there's lots of ways that coders of all flavors can take advantage of the features of Spatial. I just mentioned for the no-code sort of self-service users, there's Spatial Studio, and over on the right is sort of the whole geospatial industry. So all of the both commercial and open source tools, developer kits, service delivery platforms, commercial data, geospatial integration or sort of ETL format conversion tools, all that stuff. The entire industry supports Oracle Spatial and has for forever, which makes the whole environment just really sort of agile and interoperable, so that you can really blend the tools and technologies you choose to use for different initiatives that different teams want to use, et cetera. So that's sort of a nice, important advantage. So that's all the sort of the preamble, the setup to introduce really the topic for today and tomorrow, which is the fact that everything happens not only somewhere, but also at some time. And so what I want to do with these pair of sessions today and tomorrow is just to introduce some examples of where the things you do with Oracle Spatial you can extend into the dimension of time in a few different ways. And I'm sort of organized it into these four categories. First, just exploration, and that's the most, I guess I'll feel like Captain Obvious, so to speak, saying explore, because really what I mean by that is just any spatial data that you have that just explicitly includes a time dimension in it. You can, of course, just have both spatial criteria in your queries and temporal criteria, so that you can sort of slice and filter and look at things, through slices of time. And the sort of the cartoon picture I have on the top left is just meant to show a time sort of widget filter. But that's an example of where you're looking at things at a point in time, at like events, filtering events as they occurred at different times, like earthquakes and transactions. But now I've got like a cute little map marker floating around the map to represent that a different form of space and time is, instead of looking at and filtering incidents at different slices of time, there's also looking at objects as they move. So that's more a matter of tracing and sort of streaming position of things, which would be more like looking at the movement of vehicles or objects. And that's sort of a whole different notion of spatiotemporal. So whereas the first one, explore, is meant to represent sort of patterns of where things happen to be concentrated at one time, crimes, for example, or foreclosures. Now they're happening in other places. Well, this is now looking at the motion of things. And those are both sort of visualizations. And then down at the bottom left is what I'm just saying is analyze. And that's where you're actually doing spatial / temporal calculations to really determine what both the spatial and temporal relationship between things is. What is that both spatial and temporal duration? And the examples I have here, have to do with analyzing, for example, how much time an airplane was in a given airspace. And there's obviously all kinds of implications to those sorts of use cases and others. And that's frankly analyzed, as you might imagine, with the nature of what Oracle Spatial is all about. It's that analyze bucket there that I really want to focus the most on, because I think that's the most interesting probably in terms of what spatial has to offer in this area. So we'll focus a lot on analyze. And then the last one, predict, is really just a recognition of the whole area of machine learning and predictive models, and how that's a huge deal for spatial, looking for clusters and trends, but then extending that to the spatial domain. So looking at where concentrations of things are now and predicting where they're going to be in the future. That's another important realm, and we'll touch on that as well. So now really, I just want to go through that in a little bit more detail, that set of categories, and I'm going to somewhat kind of go quickly over the kind of the visualization exploration ones, get into the analytical ones, and then time allowing, I come back in and show a little bit more of this. But here I just wanted to show that in Spatial Studio, when it comes to just exploration, the Spatial Studio is really, it's about making it easy to use the spatial features of the database, but also visualize your data and interact with it without having to do the web coding, just like you don't have to do the SQL database coding. And so this is just an example of how Spatial Studio has widgets like this time slider and animating a time slider, stepping through time, that let you look at things like, in this case, these are tornadoes that are color-coded by strength, and looking at them either by slice in time or stepping through time to look at them. So this isn't analytic per se, but it's sort of the first sort of hello world example of let's look at something in both space and time. And again, I'll come back and show how this sort of stuff is sort of configured, and the clicks that you perform in Spatial Studio to turn this stuff on. But it's really pretty simple and self-explanatory. The next example, so that was that sort of slicing data by time. The next example is the second one that I mentioned, which is more about streaming data and tracing moving objects and being able to visualize and follow them, again, in both space and time. And that's turns out to also be one of the things that Spatial Studio enables. And it enables it by allowing you to take any data that you have, that you're connected to and that you're using from Oracle database, any spatial data. If that data includes a date or timestamp column, then Spatial Studio lets you configure that data as being spatiotemporal, and allows you to tell Spatial Studio what is the streaming frequency of that data. So Spatial Studio knows how to pull updates to the data and push them to the animation in the screen. So this is really just a screenshot from an example of that. And without going through the whole configuration of how this is turned on, I just want to quickly show, for anyone that's sort of already using Spatial Studio, or even if it's not, I've just logged into Spatial Studio, and in Spatial Studio, you connect to databases as well as other sources like web services, but primarily databases. And then from those databases, you access data and then start to visualize and analyze that data. And when it comes to this example I'm talking about right now of streaming data that you want to animate, what you do is, if your data includes, again, a date or timestamp column, then amongst the properties of a data set, like, for example, what are the columns in that data set? Have you enabled caching, all that kind of stuff? You can validate the data. Well, there's also a spatiotemporal tab in dataset properties. And in that spatiotemporal tab, if you enable a data set, if you enable spatiotemporal for a data set, or tell Spatial Studio this is a spatiotemporal data set, then all you do is you configure a few items. You configure this entity ID. What that means is, what is the unique identifier of the thing that we're tracing over time? So say it's a truck ID, as we're tracing the streaming location of a truck. If it's a truck ID, then there's going to be lots of data that's going to build up for that truck ID. That's not a unique ID in a column, but it's unique to that object we're tracing. So we would select we would select the identifier of the thing that we're tracing, and there could be 100 different trucks. We're just saying it's the column that has the identifier of the thing we're tracing, and then the column that has the continually streaming timestamp and the frequency of that stream. Is it every millisecond? Is it every second? Is it every minute? Is it every hour? Because for spatiotemporal, that streaming data, it can be millisecond, but it could also be every minute at whatever interval makes sense for that particular data. And then once a data set is configured in that way, when that data set is added to a project in Spatial Studio, it automatically has the behavior that we had in this screenshot from Spatial Studio. So I'd configure this table of boats that are streaming with streamed locations, and I did the configuration I just showed you. I drag and drop it into Spatial Studio, and essentially I turn on the switch, and they just start moving according to that data stream. So it says, it's say near real time, and that there's going to be, if this is every second, then it's maybe a second or two behind the actual movement of the boats, the telemetry from the boats. So that's sort of the animation example. And still, we're still just sort of visualizing and looking at things. We haven't really hit the analytic part of spatiotemporal yet. Although, of course, because of the fact that, like in this case here, where we have boats that are moving around and we're able to harness that animation in Spatial Studio, we could absolutely be incorporating proximity and containment sorts of analyses along with what we're doing. So, for example, as these moving boats got closer and closer to, say, a particular port or the coastline, or moved in and out of different regions, offshore regions, those sorts of things could be part of what's going on in this. But I just really wanted to put a spotlight on that sort of streaming, streaming in motion spatial data for this particular example. Another one of the visualization, sort of spatiotemporal visualization features we have is the ability to, whereas the previous example was a live stream, that's just data that's being streamed in regularly, polled and visualized in near real time. Well, there's also spatiotemporal data, which is sort of, I'll call it like historical, basically an accumulated set of paths that for a particular point in time that you want to be able to essentially just load and then be able to play back, sort of like a spatiotemporal playback. And we support that as well in Spatial Studio, and we do that through a particularly popular and common format for that type of data, which are a set of formats that are supported by this open source project called Cesium. And so in Spatial Studio, just like you can connect to the database and access spatial data and work with it, like I just showed, you can also load and work with data in these Cesium formats. And in this particular case, we're showing satellites that are moving around, but it's really any data moving through space and time, and it can be visualized and animated. And I will actually just show a quick example of what that looks like as well. So back in Spatial Studio, when we're going to create a data set, which in Spatial Studio just means we're going to point to some data, usually, tables or views in the database. But when we're going to create a data set, it can be from a table or a view, data coming from any of those database connections. We could also load to the database from different common formats, but we can also create data sets from this format I just mentioned, this Cesium format, which is this 3D spatiotemporal format. And there's a few different forms of formats of data that Cesium supports. And so we talk about the different ones that we support. But just in general, it's this sort of way to visualize 3D spatiotemporal data. So we've loaded some examples of that. I showed it to you in the PowerPoint, but we just to show you that it's really just some satellite data, like this particular example is a Cesium data set that was loaded. So just to show another way of working with spatiotemporal data, this case in 3D. If I just take that data and create a project from it, well, Spatial Studio knows that the data that I just brought into this project is Cesium data. It automatically loaded this 3D globe style map along with this time widget here at the bottom. It's all sort of part of this visualization. So now if I drag and drop that in, I just automatically get a view of these satellites, and I could actually now, using this widget here, I can press play, and you can see that I can speed it up to a silly speed. But you can see things are now moving along, and at the bottom you can see the time domain, and we can also sort of filter. We can also filter and look at individual paths. In this case, these are satellites, but these could be anything. These could be, vehicles moving through terrain or what have you. So again, just another sort of example. Now, in this case, this is not Oracle Spatial, the database, doing this. This is Spatial Studio doing this, but it's sort of doing it in concert with the rest of the features in Spatial, because this viz could sit alongside other visualizations that we have when we are using Spatial in the database. So moving past those visualizations, we now get to the real, what I would consider to be the kind of the main thrust of what I wanted to get at from the Oracle Spatial handling spatiotemporal realm, and that's these analytic capabilities. And the first one that I want to introduce and talk about now is geofencing, and then tomorrow there'll be a couple of others. So in general, what do we mean by this? So we're going to start by having defined some upfront, ahead of time, having defined some areas that are important to us because of any reason. These may be areas of environmental sensitivity, and we want to be very careful about what moves in and out of those areas, or maybe endangered species. These may be areas of secure areas for some type of public safety, or could be national security sort of scenario where there's top secret government work going on. There's tons and tons of reasons why you want to have a bunch of areas that you want to have careful control and insight into the movement in and out of those areas. So you have those predefined set of areas, and we just call those geofences. And then you can see on the right, we have that geofence, but now we have, as the arrow is showing, that there's something is marching along. The blue dots are marching along in time. And at some point, you go from a blue dot and it turns red because that red dot, that one is inside, and then it's just marching along again in blue until again it sort of crossed the boundary, this time turning green because it emerged out of that area. And that's just sort of a kind of a visual way to look at what would just be the path. But what this geofencing is all about is that as that object was marching along, the moment that it went from blue to red, meaning it traversed into the area, you see that the application above has that sort of red alert message. And then it marched along. And then when it turned from blue to green, meaning it came back out of the area, there was another message saying, that a different message saying now it's left that area. And it's that sort of awareness, it's that messaging about objects moving into and out of, or any sort of transition that's important between locations and areas, is what this geofencing thing is all about. And it turns out that there is one of the features, one of the APIs, one of the packages in Spatial Studio is all about that. And so this is sort of the conceptual view. And here's the kind of the technical, semi-technical view of how that's accomplished. So first of all, the feature that we'll use to do this in Oracle Spatial is called the location tracking server. And that's the name of a feature of Oracle Spatial. And it's been around, well, it's been in general availability since 19C. So not all that long, but it's now mature through a whole long-term release. It is a great example of why it's important for us that Oracle Spatial is not sort of a separate product that is somehow attached to the database, but instead it's part of the database. Because when we're part of the database, we can interoperate and sort of seamlessly blend what our spatial bits do in concert and combination with what other important bits and features of the database do. And when it comes to geofencing, where you're fundamentally going to be sending messages about location and getting messages back about how they relate to these geofences, well, that whole area of sending messages and building up a queue of responses that you want to subscribe to so that you can be aware of what's happening, that's something that we don't have to figure out because Oracle Database has advanced queuing to do exactly that. So the location tracking server is, it's an Oracle Spatial feature, but it's really an Oracle Spatial and advanced queuing feature because we all live, those things live together. So what this thing does, and this SDO_TRKR tracker, that's sort of the prefix that you'll see in front of all the calls to this thing. At the end of the day, all it does is it monitors the movement into and or out of areas of interest by moving objects. And so that's very clearly a space and time thing, because what's very important about that is going to be knowing not just that something moved into an area and or out of an area, but when and for how long. So the way that it works to actually work with this thing is as follows. Just like in the previous picture, we have this object being a little more specific than I was before. Now we've got a name of an object 1, 2, 3. That could be that could be a particular vehicle with its own license plate, or it could be a rail car, or it could be whatever individual object we're tracking here. And it's marching along, and then all of a sudden the next position is in region 4. And so what's happening when using this feature, what is happening is that with every position, that this object takes, or some sampling of that position, a location message is sent to this API. So for example, that in that location message will have at its core the timestamp of that position and the location of that position. So as I went from the very first, I'm going to test out the highlighter, or maybe the laser pointer. So hopefully you can see I've got my red laser pointer. So that very first position there, that position is where it starts, and then it moves to the second position. Okay, it moved. A message is sent saying at this particular time, it's now at this longitude latitude. Now it moves again. Now at this time it's at this longitude latitude, et cetera, until we go from this last blue one, and now it moves to the one where it turned red. So now, as it moves into region 4, now we're sending a message saying at this timestamp, it's now at this longitude and latitude. Well, nothing much happened for the first 5 positions, but as soon as it went into region 4, this location message triggered a message coming from the location tracking server saying that this object 123 at this time and this location has now entered region 4. And that will put a message into the queue with that information saying at this object at this time and hour, minute, second, at this location is now in region 4. That will now be a message sitting in the queue that whatever subscribing system or application is monitoring this will be monitoring that queue and will pull that message down. So you could just imagine, and just saying this, cartoon example with one object is meant just to be conceptual. And the real, power and beauty of this is really built to handle thousands and thousands of regions of interest, and maybe tens or hundreds of thousands of objects that are all moving around at the same time all over the world, and be able to handle all these cues that are reacting to movement in and out of, again, like thousands, tens of thousands of different regions all at the same time. So that's sort of a little bit more of a detailed view of conceptually what's happening. And so pointer options, turn off the laser point. Okay, so now I'm going to do a kind of a walkthrough, and I'm doing this in the form of a video for a couple of reasons, not the least of which is so that I don't have to try to type and talk. And I've tried to be pretty detailed with this, so I think it'll, I think it'll get the point across. So what this is going to be now is like an end-to-end example and demonstration of what I just talked about with geofencing. So the very first thing we're going to do is just taking a look at where we are. We're in database action, SQL Developer Web, basically. And you can see that I'm in a user or a schema called Tracker Demo. This is just my little sandbox for showing this feature. And I'm starting with, there's one table you see listed under tables, and it's TX for Texas geofences. Well, I mentioned at the beginning of this geofence piece that the one thing that you have generally created ahead of time are the regions of interest that you care about. Because we, building this feature at Oracle, we don't know what the regions are you care about. We just know sort of the structure that we're going to need to have to monitor these movements in and out of areas. But the user, the customer, will have defined what are the areas of interest. And so that's all I'm starting with. And we'll see them in a moment, but we're starting with this set of areas of interest. And then the other table, of course, is a table that's automatically created when you create a spatial index, is what this companion table is, that you don't have to ever do anything with. It's just automatically created when a spatial index is created. So that's all we're starting with. And the very first thing now to begin with that we do is to create what's called a tracking set. So the tracking set is all of the artifacts that are required to initiate tracking, geofencing. So we call it a tracking set because it's it's a few different things, but the beauty is that this one call like lays it all out, creates everything that's needed. So it involves creating sort of the data structure for where the messages are going to be stored. It creates all the sort of the messaging artifacts that'll handle creating these queues of messages. Everything gets done for us. And the parameters, these, so I'm giving a name to my tracking set. It's going to be called Texas because I'm tracking some geofencing in Texas. And then it's letting me say how many queues do I want to define for both the messages and the location. So this is sort of how I could scale and parallelize things potentially and so forth. I'm just doing a little sandbox example. So I'm only going to have one queue that I'm using because I'm not trying to scale anything right now. So I'm simply going to run that operation to create the tracking set. And then when that's done, I'm going to refresh my list of objects. So now all I did was say create tracking set. And now look at all the stuff over to the left. All I started with was this table TX geofences that I made with my areas. Everything else there. Now remember, I named my tracking set Texas. So everything here on the left starts with that tracking set name, underscore, and then just whatever, a bunch of stuff that's needed for this location tracking server to work. So I don't need to create these things or even necessarily understand the guts of them all, although it's all in the documentation. The nice thing is that it's just at this point creates the structure, and then everything else that I'm going to do to have this be working and show you, it's all just done through the PL SQL API using this structure that it created. And I'll open up the doc later. So anyone that really is curious and wants to see what all this means in detail, you can, but you don't necessarily have to make use of this. So I've created the tracking set. So you'll see that and I can sort of collapse the list of all those objects now. I don't even really need to look at them. So now we're looking at the geofences themselves that I mentioned I had pre-created, and there's 3 of them, and I'm sort of showing a pop-up with the region number. So again, you could see there was a what did I have? There's a region 9, a region 13, and a region 18. So those are my areas of interest. So I'm going to pretend those are not secure areas that I want to monitor movement into and out of. All right. So now one of the pieces of the data structure that's created for tracking is a table for those geofence areas, those regions of interest. And it's called whatever the tracking set name is, underscore tracking regions. Those are just the geofences. So the first thing I do is I'm just populating that table using these areas that I already defined. So it's an insert into, select from. You could do this any way you like, but the point is that I'm defining the set of areas, geofence areas, using these regions that I had already created. So now that I've done that, now I'm going to start the tracking set, which basically turns on the queues so that they will be listening for messages. So that when I start sending location messages, those messages will be reacted to. All right, and then the next thing that I'm going to do is to tell the tracking server, well, I have to tell the tracking server what are the objects. Right? How many objects, what objects do I want to track and against which regions do I want to track them? Because I may have a bunch of regions in Texas and some moving objects, and I may have some regions in Alaska and Belgium. And I want to tell the tracking server there's only certain objects that I want to be monitoring their movement around certain regions. I don't need to worry about trucks in Texas and regions in Belgium. So this is basically where I'm assigning the set of objects and regions that I want to be monitoring. So that's, again, just being done through a SQL call where I'm sending messages to the tracker telling it which objects are being tracked against which regions. And so now what I can do is just verify by looking at a listing of from the model, one of the tables that's automatically created is a table that tracks what is it that you're monitoring. So I'm saying I have one object. Its ID is 1. I'm only going to track one moving thing. And I have those 3 regions that we looked at. And I want to track that object as it moves into and out of each of those 3 regions. So this is basically telling me you're tracking object ID 1 and only object ID 1 as it moves into and out of regions 9, 13, and 18, which are the only 3 regions I have. And this alert when is where you can specify, do I want to be alerted only when it moves in or only when it moves out, or both? And I'm alerting on both, where it's getting an alert when it's either moves into or out of that area. All right, so now we've got this tracking server going. We've specified what the regions are. We've specified what it is that I want to be monitoring. So the next thing that I will do is to start to send location messages. So now that everything's up and running, I can simply start to send messages to this tracking server saying this object is at this location. Now this object is at that location, and just keep doing that. And the tracking server is going to tell me, it's going to create messages when that object has moved into and or out of any of these regions. So I'm going to use Spatial Studio as a convenient way to get locations, just pretend locations for this thing as for my quote unquote object as it moves around. So I'm going to drop a pin there and grab that location. So I'm going to say that's the start point. So the first message I'm going to send is that my object, maybe this is a rogue weather balloon, that's flying around. I want to monitor as it's going over a sensitive area. So it's going to start at that location. So that's going to be my first message. So I'm going to take that coordinate, I'm going to send a location message, and that's really all there is to it to send a location message. Now I'm going to move that object. I'm going to say, now let's pretend I'm going to drop a new pin. Now let's pretend that that object floated to that location. So now I'm going to send another message. And just to highlight here, you can see that what I'm doing is this is just a little PL SQL bit saying that I'm going to send a location message. The first parameter is the tracking set, which is the only one that I've got, called Texas. And then I'm going to actually send a message. And the message is going to be, the first parameter is 1. That's the object that I'm following. The second one is, what's the time of this movement? And I'm just saying it's right now, the current timestamp. And then where is it? And it's that location I just grabbed from Spatial Studio. That's the message. The message is, tell the tracking server that object 1 just now moved to this location. So from the first one I picked to the second one I picked. And so now I'm going to do that a couple more times. So now we moved out to in. Now we're going to drop a pin, grab the location. And so now that object moved back out of the region. So we'll put its new location there. So it went from out to in. Now it's back out again. Now let's move that object into region. I think that's 13. So we'll grab its location, send another message. Now, what I'm doing manually here, just for demonstration, of course, this is all like automated, and these are systems that are getting data feeds and then pushing them and making calls and building up these message queues. But I just want to show every step manually. So now I've done a bunch of movements of that object. Now I'm going to select from another one of the tables that was automatically built by the tracking server. So Texas, again, is the name of the tracking set. But now this table is notification QT, QT meaning queue table. So this is the set of notifications that this tracking server has generated based on those movements that I made. And remember that we went in once and then out once and then in again. So that should be 3. Well, actually, the very first message that I send, it starts from being absolutely nowhere to being outside of all the areas. So it turns out that the first 3 messages are saying that we're starting outside of all areas, and then the subsequent messages tell me when we move into and out of different areas. But the point is that you can see that automatically a bunch of these notifications, a bunch of these messages have been generated based on the movement represented by the messages that were sent. So now we've got some messages in the queue, but the way that that's just the queue itself. It's sort of a kind of a structure that's just meant to be the information that you're going to pull down and do something with. So essentially, we were just now demonstrating sending messages to the server saying this thing's moving around. Now we're playing the role of, now I'm like a consumer of this information. Now I'm all of a sudden I'm the part of the system that wants to know. I'm the part of the system that wants to know, has something moved in or out. I'm the one that's like monitoring for alerts or generating alerts. And so what I'm doing now in this bit is to look at the queue for any messages that have popped up. And if they have, I'm going to pull them down. I'm going to dequeue them. I'm going to pull them down and read them and see what the message says. So it's sort of, think of it like the sending the messages was the publisher of positions. And now I'm sort of the subscriber saying, I want to know what's going on and has someone breached our area. So this is now just another set of calls to the tracking server, sending a message, in this case, to dequeue or get messages from the queue, to read location messages. And you can see there's the bunch of detail in here. It's not long, it's not really super complicated. And I'm happy to share any of all this like little demo script. You could do the same thing. But the point here is that now I'm monitoring, like every 2 seconds, I'm waiting to see, is there a message in the queue? If there is, pull it down and persist it somewhere that I can use it, work with it, take some action based on it. So I'm going to run this right now, even though, again, operationally, this is something that would be constantly polling for messages. So I run this now, and I'm going to see the result, because what I just did by running that was to put whatever messages were in the queue into a table called Texas notifications. So these are the sort of the human readable messages from the queue. And you can see that the first three are saying that I'm starting outside of all three zones. And now there's a message number 4 here. I just moved inside. That was the first one where I moved inside area 9. Then when I moved outside, I got a new message saying at this time, at this location, it's now outside. And then I moved inside at another time. So now we've basically built up a spatiotemporal data set that we could use for all kinds of things. I mean, we could now measure how much time was spent in that area, how much distance was, spent in that area. If we have a fine-grained enough path that we wanted to be monitoring. And we could take, there could be instant action. Like, for example, if a position is now inside, what's the nearest resource to that position that's needed to react to it in some way? So this one is, very clearly spatiotemporal analysis in terms of doing, of course, there's lots and lots of sort of point and polygon operations at scale, which Oracle Spatial is really, really good at, but capturing that time domain also and using queues to be able to sort of operate in a messaging framework. So I'm going to defer.
David, maybe before you, yeah, right, or maybe before you continue, maybe it's worth briefly mentioning, like you just said, this is all based on queues. We had a bunch of questions about, can we use Kafka to ingest data? Where does the data come from? Is this event-driven, and so on? As you've been showing the entire infrastructure on the basis of PL/SQL and table structures with the messaging queues and so on, it may be worth emphasizing one more time that this is a fully event-driven architecture, meaning because this is all sitting on top of the Oracle queuing infrastructure, we can ingest data from Kafka, from Oracle Stream Analytics, from anything that speaks JMS or whatever kind of messaging system you have that can push data into a queue. And then when state changes happen, as David was just saying, then this actually raises an event, meaning, again, if you have an event-driven architecture, that you can, react upon this event. So this is not just plain relational technology, but this is a fully event-driven infrastructure. And I just wanted to make sure that everybody is clear about that. I mean, you've said it, but I just wanted to emphasize.
That's 100%. That's like that is really the huge takeaway. So I think it's absolutely right to really reinforce that. And where we're sending these messages, like Hans just said, to this sort of messaging queuing infrastructure, where these location messages are coming from, if whatever sort of streaming source is responsible for those, as long as they can be formulated into these sorts of messages, we're good to go. Because the only thing from we're persisting a priori up front, we're persisting those geofence areas. Of course we are, and we're Spatial's really good at doing that. And we can harness whatever, like, again, to reinforce what Hans said, we can harness whatever source it is that is feeding these constantly changing positions, and all they need to do is to be cast into location messages through this PL/SQL API. So if they can be captured in a context that allows you to send a location message like this, then it'll work, Kafka or otherwise. So yeah, well, are there any other? I wasn't monitoring the Q&A, obviously.
No worries. We've taken care of the questions.
Other,
I think we covered them all.
Did you? All right, cool. Yes. So yeah, I guess, and I guess this is sort of like a 23-hour intermission, and then we'll reconvene tomorrow again at the same time and cover a couple of other topics. And like I mentioned, this is anyone that really just wanted to kick the tires and play around with this can be in touch, because we can sort of package this up to a script that you could run step by step to do the same thing. It does work on autonomous database, and really really like a great, I think in the broader sense, a shining example of Spatial being part of this converged environment. So with that, I will turn this back on, and then Karen, I want to grab the announcement for
tomorrow.
Yes.
So
I'll let you go, Karen.
Yeah, as already mentioned at the beginning, we've split this session into two parts. So the second part we will be talking about tomorrow. So David is going to show you the rest of the fancy stuff. If you have time to try out something today, we would love to hear your feedback tomorrow. Or if you have time to digest everything and there are any more questions coming up, we will have time tomorrow as well to answer those questions as well. For today, yeah.
Did you want to say anything about this one?
Yeah, of course. I can already announce the session that will follow the one tomorrow, which is now planned for the end of March. So we have two sessions in March, but the one starting with the 1st of March and one at the end of the month. And there we are going to talk about very typical use case and task to get started with spatial data, which is called geocoding. And by geocoding, we mean that you typically have a set of address data or place names, which you first need to convert into coordinates in order to be able to map them on a map or to point them on a map. and to work in an analytical fashion with this kind of data as well. So stay tuned. This is planned for March. Thanks a lot, David, for today, and hope to see you tomorrow at the same time as today.